Today we're going to continue our discussion of parametric equations. Remember, a parametric equation is just another way we can write a rectangular coordinate. Let's say we have y equals sine of x plus 4. This is our rectangular coordinate. And if we want to write this as a parametric, all we do is we want to write this in terms of something x equals and y equals. So in other words, x and y are independent of each other. So to do that, we need a third variable, t. And for the easy part, let's let t equal x right here. So if I let t equal x, and of course x is equal to t. Our parametric then is going to be this. Y equals the sine of t plus 4. And there's our parametric equation. Let's take a look at maybe another example. For example, a parabola. Y equals x minus 4 squared minus 7. And what we can do here is we can let this whole equation equal our t. Well, you can let, of course, this x be t, and then your parametric be x equals t, y equals t minus 4 squared minus 7. But sometimes we want, especially for parabolas, we want to make it a little bit easier. Make it a little bit simpler. We can let t equal x minus 4. So if I let t equal my x minus 4, my inside, well, what will x equal? It will be t plus 4. And then what's y going to be? Y equals, t, whoops, we already had the y equals, silly me. Y equals t squared minus 7. And there's our parametric equation. And of course, we also talked about even if we had a conic, like an ellipse, x minus 3 squared over 4 plus y plus 1 squared over 9 equals 1. And for this one was a little bit tougher to do because we had to use our Pythagoreans. Cosine squared of t plus sine squared of t equals 1. And we just, of course, matched them up. Cosine of t, that's our square. Take the square root, we get x minus 3 over 4. Sine of t equals, we just match those up, y plus 1 over 3. Whoop, that should be over 2 because we had to take the square root of both sides. Cross multiplying, we get x equals 2 cosine of t, and we would add the 3. Over here, we would get y equals 3 sine of t minus 1. And there's our parametric equations. These are always a little bit harder to do. More fun, though. What I want to spend more time today is to go over how we can write from parametric to rectangular. And we're going to take a look at that. To go from parametric to rectangular. And that's what we're going to talk about today. To do this, we use a method called eliminating the parameter. Eliminating the parameter. In other words, get rid of t. And a nice example is something like this. Let's let x equal t plus 3 and y equals 4t squared. Something like this. Okay? So what we're going to do to eliminate the parameter, we always want to have solved for y, because equations, we normally want y solved for. So to eliminate the parameter, I'm going to look at this x equals t plus 3. And I'm solving for t. T equals x minus 3. So that's what t equals. And I'm just going to plug this into my y equation. So we now get y equals 4x minus 3 squared. And of course, this is a parabola. Very easy to do. Matter of fact, let's take a look at kind of another one, a little bit easy to do. Let's see here. Y equals 3 minus 1 over t. Ew. Okay, looks bad. And x equals that. Y equals t plus 1. So solve for t here. Okay, don't be too fancy. If I have x equals 3 minus 1 over t, I'm going to subtract the 3, or multiply everything by t if you want to. You don't have to, but the easy way to do is just subtract 3. So we get negative 1 over t equals x minus 3. I'm going to do two things, flip it, and change the signs. This becomes negative 1 over x minus 3. Negative because I just take out the negative. And I'm flipping both sides, and that's what we get. It's our inverse. And now I'm going to take this and just plug it into my y. We get y equals negative 1 over x minus 3 plus 1. And you get a rational graph right there. And of course, you can do this with all sorts of problems. Watch this one. Let's do this one with absolute value. Y equals the absolute value of x. Whoops, that should be a t. Let's start over here. Y equals the absolute value of t plus 3. And on the bottom, y equals 3t. And I want to do this. Eliminate the parameter. Let's take a look here. X equals the absolute value of t plus 3. To get rid of absolute value, we get plus or minus x equals t plus 3. So what's t going to equal? Plus or minus x minus 3. And that's what we plug in. We get y equals 3 times plus or minus x minus 3. Distribute plus or minus 3x minus 9. And if you notice, we get 2 lines for this one. And you can kind of sketch it. They both have a y-intercept of negative 9. One has a slope negative 9. One has a slope of positive 3. And the other one has a slope of negative 3. Very easy to do. Now, there's another way you can look at this. Normally, we would have to restrict the domain. And we'll talk about that maybe later on, okay? All right. Let's take a look at one where it involves trigs. Okay? Let's take a look at a trig one. Another example. Let's see here. Let's let y equal 2 sine t minus 1. Y equals 4. Sorry, that should be x equals, and that should be cosine. Ooh, don't mess that up. Don't mess that up. That should be x equals 2 cosine t minus 1, and that y equals 4 sine of t. Well, to do this one, because of this, we're going to use our Pythagorean. Because of our cosine and sine, we're going to use our Pythagorean. Cosine squared of t plus sine squared of t equals 1. We'll use our Pythagorean identity. So we have to solve for cosine and sine. So solve for cosine. X equals 2 cosine t minus 1. Y equals 4 sine of t. Solving for cosine of t, we're going to get x plus 1 over 2. Solve for y, or sine of t equals y over 4. And then we're just going to square these. This becomes x plus 1 squared over 4. This becomes y squared over 16. And according to my Pythagorean, I just add those together, set it equal to 1. We can even do more complicated ones. Let's do this one. X equals the tangent squared of t minus 1. Y equals 3 secant squared of t. Now be careful for this one. This is tangent secant, okay? So if I do cosine squared plus sine squared equals 1, I want tangent, so I have to divide everything by cosine squared. And this is going to give me 1 plus the tangent squared of t equals the secant squared of t. So the relationship is this. Secant squared of t minus the tangent squared of t equals 1. And there's our relationship we want this time. So I still have to solve for tangent, and I still have to solve for secant. Tangent squared of t will equal this, just x plus 1, and we get the secant squared of t equals, this just becomes y over 3. Now notice, unlike the last one, do we have to square them? No, they're already squared. So I can just plug this in. So my rule, secant squared, y over 3 minus my tangent, x plus 1 equals 1. And if you notice, this is kind of a cool one. This is actually the shape of a line, because all my powers are 1. This is a line, and you can solve for y if you want to. All right, go to part 2, and we'll look at some graphing.